I think fascinating topic today. We're going to talk about poisons, venoms, and toxins, and they're not synonymous. So that's the first thing we'll clear up. But I'm not going to teach you how to poison people, although there are people out there who need to be poisoned. Yeah, I don't know how I could get my hands on Dubai's coffee or food or whatever. Anyway, let's get going with a couple of definitions because, as I told you, these terms are not synonymous. So, poison is pretty straightforward. It's any substance that is capable of injuring you. That's what a poison is. Now, if it is made by a living organism, whether it is an animal or whether it is a plant, then we call it a toxin. Okay. Now, this is the scientific definition, but generally, it gets all mixed up. When you read books, when you read the media, they use poison and toxin interchangeably, but scientifically, this is what the story is. Now, if that poison or if that toxin is delivered by a sting or a bite, then we call it a venom. So these are the interesting differences between venom, toxin, and poison. So obviously, all toxins are poisons, but not all poisons are toxins. Okay, which sounds a little bit confusing, but I think we'll be able to clear it all up. There's a very simple way to remember it. If you bite it and you get sick, it's poisonous. If it bites you and you get sick, it's venomous. Okay, but in both cases, you are exposed to a toxin. Okay, so that really encapsulates it all. So let's start out with substances that are poisons, but are not toxins, which means that they are dangerous, they can do you harm, but they're not produced by a living organism. So a classic example would be cyanide, potassium cyanide, right? It's not produced by a living organism. And in its pure form, potassium cyanide is a white crystalline material, very dangerous when you swallow it. But even more dangerous than that is hydrogen cyanide, HCN. And it's a gas that can be inhaled. But whichever way cyanide gets into your body, it interferes with the way that your cells use oxygen. You can't live without oxygen, right? Every single cell in your body needs a continuous supply of oxygen. If there isn't enough, you die. However, even if there's enough oxygen that is inhaled, if the cells for some reason cannot use it, you still die. And that's what cyanide does. So there can be enough air that you're inhaling, there can be enough oxygen getting into your body, but it cannot be used because cyanide ties up the enzymes that the cell needs in order to use oxygen. The most notorious use of cyanide, of course, was the gas chamber. And this is where Zyklon B became famous. Now, Zyklon B is sort of interesting because what it actually is are little granules of inert material, either something we call kieselguhr, which is a kind of clay, or gypsum, but these are very porous substances that can absorb the gas. So generally, the way that this was produced was to take potassium cyanide, add an acid to it, which then converts it to hydrogen cyanide gas, and the gas was then absorbed into the clay-like material. So what you had in the canisters there was, if you saw it, it was just granules. But as soon as you open the capsule, the granules will release the hydrogen cyanide gas that was stored in there. And it results in a very, very quick death. Also, in the same category of being a poison, but not a toxin, again, because it is not produced by a living organism, would be arsenic. Arsenic, of course, is maybe the most famous poison. It's been referred to as the king of poisons, right? And there are some very interesting stories about it. If we go back to the Borgias in the during the Italian Renaissance in the 16th and 15th century, the Borgias, who were originally a Spanish family, but moved to Italy, had huge influence in Italian politics and also in the religious aspects of Italy, and they were able to get two popes elected, and they had a huge influence on what was happening in Italy at that time. And as the story goes, they got rid of their enemies with the use of arsenic. Now, it's often hard to know exactly what is historically accurate or not. I mean, we debate historical events of just how they happened, 40, 50 years ago, right? So 500 years ago, you're never really quite sure whom to believe and, which accounts are accurate. But what is known is that arsenic has been recognized as a poison for a very, very long time. But perhaps the most interesting and famous cases of poisoning by arsenic were by a substance called Paris green or Sheila's green. And this is an arsenic compound, as you can see, and it is a green dye. And it was used in the 19th century extensively to color wallpaper. This was the green era, as it was called. It was also used to dye fabrics. So Paris green was a very commonly used substance. However, it can slowly release arsenic into the air as arsine, which is ASH3, that can be inhaled. And there are numerous cases of documented poisonings of people who lived in homes where the wallpaper was made with arsenic pigment. But perhaps the most famous case is that of Napoleon, who, of course, was exiled to Elba and under British rule. And the story is that the house where he lived, apparently relatively comfortably, in exile, was green wallpaper. And the story is that Napoleon actually died of arsenic poisoning. And there is some evidence for that because his hair did have residues of arsenic. There are also other stories that the British purposefully poisoned him by putting arsenic in his food. It's hard to know. But maybe the most celebrated massive poisoning of with arsenic happened in Bradford, England. And this happened on Halloween Eve in 1858. Because already Halloween was celebrated at that time, kids were doing trick-or-treating and people were giving them candies. Well, it turned out that some of these candies had been accidentally poisoned with arsenic. Now, I say accidentally, although there was a criminal angle to this, because the manufacturer wanted to save some money by using less sugar in a candy. Sugar at that time was still quite expensive. The sugar plantations in the Caribbean were just starting to be built. And of course, that has a terrible history as well because there was a lot of slavery involved. So anyway, sugar was expensive, but there were other substances like plaster of Paris or gypsum, which were very cheap and were white and looked like sugar. So they would often try to dilute sugar with that, so to bulk up the weight, and they would charge the weight of sugar for gypsum, right? Which obviously was a criminal activity. But anyway, the accidental part of this was that a pharmacist assistant unfortunately ladled out arsenic, which looks like white crystals, arsenic trioxide looks like white crystals, ladled that out instead of the gypsum that was supposed to be mixed with the sugar. Well, nothing should have been mixed with the sugar anyway, but this was the mistake. Apparently, the pharmacist assistant legitimately made that mistake. And as you can see, it resulted in at least 20 children dying, probably more, because records were not so properly kept. And, many people in those days died without anything ever being registered. So death statistics were, not so reliable. But anyway, that was a terrible case of large-scale poisoning. Uh, but it is also very interesting that arsenic, believe it or not, had a medical use as well. What was that? It was arsenic complexion wafers. These were thin little wafers that contained arsenic, because one of the consequences of ingesting arsenic is that it makes the skin whiter. And in those days, white skin was desirable, because it was only people who worked out in the fields who had bronze faces. So if you wanted to show that you were of the gentility and you were not a common peasant, then you'd want to look white and take arsenic wafers. And undoubtedly, there were some people who were poisoned by that. Now, of course, the worst sort of scenario with arsenic when it is used for deliberate poisoning on a large scale. And this was an issue that arose near the end of the First World War. And again, herein lies a very interesting story. In 1904, Julius Newland, who was actually a Catholic priest, but also a chemist, and he carried out a reaction in 1904 when he reacted acetylene with arsenic trichloride, simply because this was something that had never been done before, and he was just investigating these, unknown reactions. And he inhaled some of the stuff that he produced and ended up in hospital for several days. He had inadvertently produced an arsenic compound, that one, which eventually came to be called lewisite. And the reason it came to be called lewisite, because it was reinvented by Captain Winford Lee Lewis in 1917. So Newland's discovery in 1904 that resulted in his having a reaction to his invention, that lay dormant until 1917. I mean, nobody wanted to play around with that. But during the First World War, when it was clear that the Germans had unleashed chemical weaponry, right? They were using chlorine, for example, as a poison gas. The Allies also wanted something to retaliate. So Captain Newland looked through the scientific literature, and actually he was guided by Newland's PhD advisor, so who knew what Newland had done. And he rediscovered this chemical, which was then named after him. So that's why it became lewisite. Interesting thing about this is, by the smell, you would not know that this is a dangerous material because it smells like geranium. So both the British and the Americans stockpiled this in case there would be another war, because this was near the end of the First World War. It came to be known as the dew of death because it very quickly killed rodents. And of course, they had the evidence from Father Newland that it could harm humans as well. The question was, how was this doing it? Why was arsenic so toxic? And by the 1950s, it became clear what really was happening here. And it's actually a pretty simple idea. Proteins, which of course are extremely important molecules in biochemistry, because everything, our muscles are made of protein, our enzymes are made of protein. And these molecules have sulfurs on them. Now, it turns out that arsenic has the ability of forming chemical bonds to the sulfurs. And what that does is inactivates the protein. So it cannot do its job, and that results in death. Well, near the end of the Second World War, when there was still, this worry about using poison gases, researchers at Oxford University in England came up with what came to be called the British anti-Lewisite, which was the antidote to Lewisite. And it's pretty interesting because, as you can see, this molecule also has two sulfurs, just like the protein. So what happens is that the arsenic is tied up by this antidote, so it doesn't have a chance to get into the body. This chemically, it was known as dimercaprol, and it was an injection, and if someone was exposed to the poison gas, an injection would reverse the situation. It turned out that after the war, that this molecule, British anti-Lewisite, not only was able to neutralize arsenic, but the same way it was able to bind lead and gold and copper and other heavy metals. So out of this discovery actually came a drug that is still stored today in emergency rooms in every hospital in case someone has heavy metal poisoning, lead and mercury being the classic examples. They would use British anti-Lewisite. So it's interesting how out of this chemical warfare research, we now have a drug that actually saves lives. So, but all of these substances were poisons, but not toxins, because not produced by any kind of living species. So when we look at toxins, then we're starting to look at substances that come from living sources, but they fall into the category of either being a poison or being a venom. So let's look at these. The most obvious example, of course, of something that is venomous but not poisonous are snakes, the rattlesnake. Well, what do we mean by the fact that it is venomous but not poisonous? It's not poisonous because you can eat it, right? And they do in the southern U.S. It's pretty common food, right? We don't have it here, although I think in some places you can buy canned rattlesnake meat. Is it kosher? I don't know. I don't know. It's not an insect. Yeah, I think it would be. I think it would be. It would need a mrzgia for its preparation, but anyway, it's usually described as eating chicken. Why not eat chicken? Yeah. Anyway, but obviously it is venomous because you don't want to be bitten by the rattlesnake because, of course, you'll get its venom into your bloodstream. But the venom is not distributed through its body so that you can eat it. On the other hand, the pufferfish is poisonous, but it's not venomous. Although it has those spikes on its body that it can elevate when it feels that it is in danger, those are just physical spikes. They don't inject anything. They just deter a predator. But inside of its flesh, it does have tetrodotoxin, which is one of the most potent poisons that you can ever come across. So eating the pufferfish would be lethal. But people do eat pufferfish. In fact, it is a delicacy in Japan. You have restaurants that specialize in pufferfish. It's called fugu when it's prepared as a meal. So how can it be that this is so poisonous and yet people eat it? Because the poison is only in certain parts of the fish. It is in certain parts of the nervous system. And chefs are specially trained to eviscerate the fish in such a way that they take out all the parts that are that contain the poison, and then you can eat the rest of the fish. And people do. It's served as a delicacy. It's very expensive, uh, but it seems to be a big deal in Japan. And apparently, no matter how well it is prepared, there's still a little bit of tetrodotoxin that is left in the flesh. So that when you eat the fugu, you will get some tingling in your extremities, in the fingers and in the toes, which will slowly go up. And if it stops short of your elbow, you're fine. You go ahead and enjoy the meal. If it goes past the elbow, you can still enjoy the meal because you're last one. Uh, you know, the American public actually learned about this whole business of fugu from that icon of intelligence, Homer Simpson, who was in a Japanese restaurant and was served fugu, and he started to have some tingling, and he found that he figured that it must not have been properly prepared and that he only had a few hours left to live. And the whole program focused on that. It turned out that that wasn't the case. He hadn't actually ingested the fugu, but at least it did teach the American public about this whole business of the pufferfish and fugu. But although Homer Simpson was saved, there are many others not, because there are statistics on this. The most recent ones, though, are much more comforting. I think last year there were no reported cases from any restaurant where fugu was sold. And almost all the cases where people have been poisoned is when they have tried to prepare it themselves. So you really have to rely on the chefs who are trained to do that if you ever want to try it. Has anyone been to Japan and tried that? Maybe the ones who did are not here. All right. But there's another interesting connection to pufferfish poison, to tetrodotoxin, and that is with James Bond. In From Russia with Love, which was the second James Bond movie, starring Sean Connery, who of course was James Bond, right? All the others subsequently were actors playing the role of James Bond. But in Russia from Love, the whole plot, or at least a major part of the plot, centers around tetrodotoxin, where Bond is confronted by a Soviet spy and gets kicked by her in a fight. And she has this little knife that snaps out from her shoes. And of course, it is coated with tetrodotoxin, and Bond gets killed, or at least drops. It seems like he gets killed. But the fact is that he does survive, as we find out later. But the truth is that there is no antidote to tetrodotoxin. So what's the story here? Well, actually, in Dr. No, which was a book written by Ian Fleming after he wrote From Russia with Love. Although the James Bond movies were the other way around. The first James Bond movie was Dr. No, and then came From Russia with Love. But in truth, Ian Fleming wrote these books in reverse. So in the first book, In Russia with Love, he tells the story, just like the movie does, of Bond being kicked by the tetrodotoxin. And then in Dr. No, the subsequent book, he explains of how Bond was able to recover from this, wrongly. But here is what he said, or at least this is what the book says. There was a physician who jumped to the rescue after Bond had been kicked by the poisoned blade. And he surmised from the symptoms that Bond was showing that he had been poisoned by an extract of a plant grown in South America that we refer to as curare. Now, curare is a fascinating material. It is highly poisonous. It is what was used on the darts by natives in South America in their blowpipes. And monkey would be jumping from tree to tree. It would be hit with a poison dart and immediately drop. So it was very, very a toxic substance. So curare works by blocking what we call a neurotransmitter. Neurotransmitters are chemical that send messages between nerve cells. If you block that transmission, then nerves don't function properly and you can be paralyzed. So anyway, in Dr. No, Fleming explains that this doctor who jumped to the rescue diagnosed Bond with curare poisoning and treated him with an antidote called physostigmine. Now, this actually would have worked. Physostigmine is an antidote for curare poisoning, except that Bond was not poisoned with curare. He was poisoned with tetrodotoxin, for which physostigmine would have done absolutely nothing. But physostigmine is a very interesting substance. It is extracted from the calabar bean. And this is it's a plant that grows in Africa. Calabar is actually a region of Nigeria. It's down there at the bottom of Nigeria. And in African culture, it has long been used as something to detect criminal activity in what was called trial by ordeal. What was a trial by ordeal? The accused person would have to swallow the seeds or the beans of the calabar plant. And if they vomited, then they were judged to be innocent. If not, they would be punished because they would die from the calabar bean. I mean, obviously, this is not a way that you can detect criminal activity, but apparently this still goes on in some backwoods parts of Africa, this trial by ordeal. That's how you determine if someone is guilty of a crime. Well, talking about guilt and crime, Agatha Christie, of course, was the master of such stories. And in Curtain, which is the last Hercule Poirot story that she wrote, in which Hercule Poirot actually dies, there was also a murder, and it was done with physostigmine. It's not surprising that Agatha Christie had so many poisons in her stories because she had training as a pharmacist. During the First World War, she actually worked as a pharmacist assistant in a hospital. So she was very up to date on drugs and poisons. And just about every one of her stories has some connection to poisons. But that's fiction. This is not fiction. Putin actually does carry out murders with a very similar substance. Novichok, the chemical that you see here, is in the same chemical family as physostigmine. What it does is it enhances the production of acetylcholine, the neurotransmitter that I just talked about before, and it eventually results in respiratory problems and it stops the heart. And there have been a number of cases. The most famous one was the so-called Salisbury murders in England, where Putin apparently ordered the murder of two Russian emigres who were acting against the Russian government. This was a huge story in Britain. And I think that there's no doubt about the veracity of this, that this really was ordered by Putin, Trump's great and good friend, right? Another absolutely fascinating poison is the one that is produced by the poison dart frog. Who would ever thought that these cute little beautifully colored frogs found in South America would harbor a deadly toxin, and that is batrachotoxin, complicated molecule. Again, as you can see, it blocks transmission of nerve signals, and it is more toxic than curare and more toxic than tetrodotoxin. And it is used on poison darts, and it has been for centuries in South America. And this is the way that it would be done. You do not handle the frog. So you hold it down, and then you rub the tip of the dart on the skin of the frog. And the frog is feeling threatened, so it releases its toxin through its skin. You can coat it on the dart, and it is extremely poisonous. And by some quirk of fate, it turns out that there is another creature, and only one other creature in the world, that produces batrachotoxin. And that is the pitui bird that lives in New Guinea. It is the world's only toxic bird. And its feathers get coated with this toxin, which obviously protects it from predators. And it isn't really clear how it produces the toxin, but probably the same way as the frogs. That also has been researched. It's very interesting because when those poison dart frogs are raised in captivity from birth, they don't produce the poison. So it is obviously something in their own diet that produces it. And it's probably some sort of insect in the rainforest that those frogs live on that is the precursor for the production of the poison. And the pitui bird probably eats the same kind of insects. Anyway, it's not clear how either the frogs or this bird produce it. All right, so that's pretty interesting, but we're going to flip back for a second once more to James Bond, and this time in Octopussy. How they ever got away with that title is really something. But anyway, they did, and this was Roger Moore, not Sean Connery anymore. But here in this movie too, tetrodotoxin plays an important role, because here James Bond has to confront the blue-ringed octopus, which is one of the most dangerous creatures in the world. Now, it is dangerous because its flesh contains the toxin, but it also bites. The octopus bites. Most people don't know. All octopi bite. They have a mouth, and if you bother it, it will bite, and it will inject the tetrodotoxin into people. And James Bond has to confront with it. There's a classic scene in there where the octopus jumps onto the criminal's face, and of course he immediately dies. It's a very pretty creature. So if you ever go scuba diving, leave it alone. Yeah? You don't want a confrontation with this. But I think in terms of venoms, which are injected poisons, as said, obviously the most famous are snakes. They are venomous, right? Not necessarily poisonous, as we saw with the rattlesnake, but their bite is lethal. I think you'll be shocked by the number of deaths a year globally from snake bite, because one would think this is a rather rare occurrence, right? It's about 125,000 people a year who die from snake bites, mostly in India, right? Which, of course, is now the most populous country in the world. And it has a high number of snakes. Anyone know after India, what country would have the most snake bites or deaths from snake bites? No, it's Australia. Actually, Australia has more venomous animals than any other country. Yeah, there are a lot of snakes in Australia. All right, so obviously, given the history of snake bites, there have been vigorous attempts to try to find antidotes to snake venom, and this effort really goes back to Albert Calmette, as you can see in the late 1800s, and he was caricatured there, as you can see, surrounded by snakes. He became interested in the Indian cobra, which is one of the most venomous snakes. And he wanted to find an anti-venom for this, because nothing at that time was known. There were no medications if you got bitten by a snake. But Calmette was aware of Emil von Behring, who had received the first ever Nobel Prize in Physiology and Medicine in 1901. That was the first time the Nobel Prizes were awarded. And von Behring had received that prize for having essentially conquered diphtheria, which is a terrible bacterial disease. It causes diarrhea. It was killing children. And what he found was that when he injected the bacteria that caused diphtheria into horses, and then he isolated the horse's blood, separated the red blood cells from the plasma, he found that the plasma contained substances that acted as an anti-venom, that is, an antitoxin against the diphtheria disease. It would kill the bacteria. This obviously was a tremendous discovery. Today, of course, we don't refer to this as antitoxins. What do we call them? Antibodies, which are produced in the body in respect to a foreign intruder. So anyway, Calmette was aware of this. So he thought, well, maybe this can work with snake venom as well. What if you would inject a small dose of snake venom into a horse? Would the horse then produce antibodies to that? And it turns out that yes. So he was able to come out with an anti-venom for the cobra. And the cobra has a very, very poisonous bite. And it was done with the same technology with horses. And indeed, this is how all of the antivenoms today are produced. Whether you're talking about snakes or whether you're talking about scorpions, for whatever creature an antivenom exists, it is done by injecting a small amount of the toxin into the horse, separating out the red blood cells from the plasma in the horse's blood, and isolating from the plasma the antibodies, those that can be injected into the victim, and most of the time they are safe. The trouble with snake antivenom is that snakes don't have a uniform venom. The different snakes have very different chemistries. So you need an anti-venom for every different kind of snake. And it doesn't exist. There's no universal anti-venom. So if you ever get bitten by a snake, it's very important to know what the snake is. So don't run away. Ask it what kind of snake, so that you can tell them in the emergency room what is. Now, there are some antivenoms, as you can see, the one on the right there, which would work against a number of snakes. But it's very important to know exactly what kind of a snake it was. What? The horse is fine because you're injecting a very small amount of the venom. So all the horse does is produce antibodies to it. It's essentially the same idea as vaccination, right? When you get a vaccine, what your body does is it produces antibodies to that vaccine so that the next time that your body is confronted with the same material, the antibodies are there to fight it. So same idea. Now, snake venom, of course, gets a lot of bad publicity. But the fact is that snake venom can also cure. Believe it or not, there are drugs that are derived from that. This is the Brazilian pit viper, so called because behind its eyes it has little pits in its head. It has a very, very potent venom. However, as you can see, turns out that when they examined the venom of this, it turned out to have an effect on blood pressure. And based upon the molecular structure that they determined of this venom, they came up with captopril, which is still a widely used antihypertensive. That is a drug to lower blood pressure. So it comes from snake venom. And another very interesting drug that comes from such a source comes from the cone snail. This is an extremely interesting creature. I mean, it looks interesting. It lives in the ocean, right? So you're not likely to come across it. And it looks like a cone. Obviously, that's why it is so called. But it has what looks like a little spear. You can see it at the right side. And whenever it feels that it's threatened, it actually shoots this out, and it hits the target. It hits the invader and injects a neurotoxic venom. So it is able to protect itself in that way. Well, it turns out that by analyzing the toxin that it injects, they were able to come up with a drug, this synthetic peptide, which is used for very severe pain. Because there are cases where people who have such pain that morphine or oxycodone are not adequate enough. And then you have to resort to something that is more potent. And this one has amazing pain-killing effects, except that it does have to be injected into the cerebrospinal fluid. Another fascinating venomous little creature is the Gila monster. And this is getting a lot of publicity these days because an analysis of its saliva, which contains a toxin, and whenever it bites a predator, it will transfer the toxin. Based upon the chemistry of that toxin, they were able to come up with a medication that is now becoming very, very famous. And these are the so-called GLP-1 agonists. And the first one that was introduced was Byetta. And this was based on the chemistry of the Gila monster venom. And it curbs the appetite. And of course, subsequent versions of Byetta is what gave us Ozempic, which today is the most widely sold drug. Now, in many of the articles that you may read about Ozempic, they will refer to the Gila monster, and they kind of suggest that Ozempic is isolated from the saliva of the Gila monster. This is not true. The Gila monster certainly gave a clue. GLP-1 is a hormone that is produced in the intestine whenever you eat. And it sends a message to the brain, okay, you've eaten enough, cut down on hunger. And it also sends a message to the pancreas to release insulin, which both of those, of course, are desirable. But you cannot use the GLP-1 hormone that the body produces and inject it because it is immediately broken down by enzymes. It's digested as soon as you consume it. So the benefit of the Gila monster was that it produces a peptide in its saliva that is not easily broken down in the body. So by analysis of the exact amino acid sequence of that peptide, they were able to eventually come up with Ozempic. So without the Gila monster, it's true, we would not have Ozempic, but it's not extracted from the Gila monster, as is very often said. Another fascinating animal is the slow loris, which is the only known venomous primate. It looks like a little monkey. It's actually in the lemur family, and it looks kind of cute, right? But it has a gland near its armpit where it secretes a substance which actually is not toxic, but it mixes it with its saliva, and its saliva contains an enzyme that then converts it into a very potent poison. So if you ever come across this cute little creature and you see it reach into its armpit and then into its mouth, then you better be careful, because then it's getting ready to use its toxin. But you're not likely to run across this guy. Neither are you likely to run across the solanodon, unless you go into the woods in Haiti, Dominican Republic, or Cuba. Funny looking creature. It kind of looks like an anteater, right? And it also produces a highly toxic material, a protease, which means that it breaks down proteins. There are other such animals, and this one actually you may come across, because you do find them in Canada, the northern short-tailed shrew. And this also produces compounds, and when it bites, it transfers it into the bloodstream. This is the Komodo dragon, and well named because it's a fearsome-looking creature. And this produces in its saliva an anticoagulant. And anticoagulant means that your blood will not clot, and then it kills. So there's a different kind of poison. Where you find it? The Komodo dragon you can find in Australia, you find it in New Zealand, you find it in Southern Africa, Indonesia, yeah. And it can be quite large. Komodo dragons, can be the size of a crocodile. This is the platypus, and that is one of the strangest creatures. The platypus, mostly in Australia and New Zealand, very funny creature. Look at its head, and it has a bill very much like a duck. But it injects a venom, and apparently it causes unbelievable pain, as this woman who got bitten by one or poked by one in Tasmania. She said this was the most painful experience that she ever had. So the platypus is also a creature that you want to leave alone when you're there snorkeling. You don't want to perturb this guy. All right, so those were animals, animal toxins, but of course there are a lot of plant toxins out there as well. Again, toxin because it is produced by a living species. Hemlock, classic example. And if you know your history, who was poisoned by hemlock? Socrates, right? Socrates was convicted of leading his students astray because he spoke against the Republic, and he was given a chance of how to die, and he chose execution by coneine, which is a poison that is found in the hemlock plant. And again, this is a neurotoxin. It blocks the action of acetylcholine, leads to paralysis and a pretty quick death. But much more poisonous than that is what is found in the castor oil plant. Castor oil plant is quite common. If you go to the Hudson Park on Westminster, you'll find a number of the castor oil plants. Now, the castor oil plant contains seeds, actually called beans, from which you can squeeze an oil. And that oil is, you can use it as a cosmetic, as a moisturizing agent, but also as a laxative. But the beans also contain a very, very potent poison called ricin, which is so toxic that the lethal dose is about 150 milligrams. A milligram is 1,000th of a gram. So this would hardly be visible to the naked eye. Now, the oil is purified, so you're not going to have any kind of reaction from castor oil. it has to be extracted from the bean itself. But the most fascinating story of ricin is one that occurred in 1978 when, again, the Soviets were behind this. Georgy Markov was a Soviet emigre, well, actually a Bulgarian emigre, but Bulgaria was in the, Iron Curtain country with the Soviets. And he, in England, he left Bulgaria, escaped Bulgaria, went to England, where he worked against the Soviets. I mean, he wrote books and articles against the Soviets. And he paid with his life. One day, he was waiting for a bus right at this bus station in London, Liverpool Station. And he felt a little pinprick on the back of his thigh. He just looked around, and all he saw was a man walking away with an umbrella. Within hours, he got very sick, and within a couple of days, he was dead. And as the story goes, the umbrella had been produced by the Bulgarian secret police, 1978. And it was equipped to inject this tiny pellet, as you can see, which has holes in it, in which the ricin poison was. And this was injected into his thigh. The pellet is very small, you can see, compared to the head of a pin. Now, how did they piece this together? Because they couldn't at first find what was wrong with him. And when they did a very careful examination of his skin, they found the pellet. So that we know for sure, that he was killed by this little pellet with the ricin toxin. The umbrella story comes from the fact that he said that when he felt the pinprick, he saw someone walking away with an umbrella. I would say that that's not 100% conclusive, but it's pretty indicative. So ricin is unbelievably toxic, right? At 150 milligrams. But there are substances in nature that are even more toxic. This here, a protein called abrin, which is found in rosary peas, very pretty peas. This is more toxic, 150 micrograms. A microgram is a millionth of a gram. You could not see 150 micrograms, and that is enough to kill. They're called rosary beans because, of course, you can make rosaries of them, and they're perfectly safe unless you start chewing on the beads. So there are a lot of interesting toxins out there produced by nature. If you've ever been to Florida, of course you have, you'll sometimes see these signs on the manchineel tree, which produces a fruit, the so-called death apple, and you'll see warnings like this. Columbus described the small green fruits from these trees as death apples. The trees are common along Caribbean shores and contain a sap that can be harmful if touched. Avoid contact. That's what the tree looks like. It's actually a pretty attractive tree, but you should not touch it because you will get skin irritation. But neither should you stand under it if it starts to rain, because the rain will drip down some of the toxin that is produced by the leaves, and you can get a terrible reaction. So if you get caught in the rain in Florida, don't look for a tree, the manchineel tree, to stand under. And as the story goes, Ponce de Leon, who of course is famous for searching for the fountain of youth in Florida, didn't find it if you look at the people in Florida. But anyway, he died from a poison arrow. And I mean, that's known. He had confrontation with the natives in Florida. And the theory is that the poison arrow was poisoned with an extract of the manchineel tree. Then there is this one, Cerbera odolam, which is known as the suicide tree. Colloquially, it is also known as the pong pong tree. And you may be familiar with this if you watched a certain show on TV. Anyone know which one we talk about? White Lotus. If you haven't seen White Lotus, you should. Very good series. I forget if it's on Netflix or wherever. It's very good. Anyway, the seeds of the fruit of the pong pong tree contain a cardiac glycoside, which means that it will stimulate the heart, overstimulate, and it can kill. And this was in the plot of White Lotus, where a gentleman wants to carry out a murder using the pong pong fruit, but then he has second thoughts and it doesn't really happen. But they do describe the chemistry very accurately. So it's and the story is very good. But one that is, I think, better known that pong pong in terms of poison are some mushroom poisons. The death cap mushroom is terribly toxic. It forms these so-called toxins, and that will kill you very, very quickly. And we have good evidence for that quite recently, actually, when a woman in Australia was convicted of murder, killed a number of family members by putting the chopped up mushroom into their food. It was a huge story in Australia, and she was sentenced to 33 years in prison. There were all kinds of newspaper accounts of this, including this one, which is actually wrong, because the picture that you see there is not the death cap mushroom. This is Amanita muscaria, which is a totally different kind of mushroom. It does also have a toxin in it, but not nearly as potent as the death cap. And death caps grow in Australia. That's why you see warnings like that. And it's pretty amazing how little of this it takes to kill someone. Finally, strychnine, which is, when you tell someone to think of a poison, they will either think of arsenic or strychnine. Strychnine is a toxin because it is produced by a natural source. It is produced by a tree. It is the fruit of the tree that contains these little nuts, and those contain the strychnine. We know strychnine, we know where it is, we know its molecular structure. We even know exactly how it poisons people. Much of this you can learn about from Agatha Christie in her very first book, The Mysterious Affair Styles, that introduced Hercule Poirot. Murder is carried out with strychnine. And again, it's very well described because she knew her chemistry. But once more, very often real life mimics fiction or the other way around. And in the late 1800s, there was a classic case in England, which was widely reported in the press, about William Palmer, who was referred to as the Prince of Poisoners. And he was convicted for murder, 1855, of his friend John Cook. He was hanged because he was found to be guilty. And it was clear during the trial that he had done this. And it got a tremendous amount of publicity at that time. I mean, remember that this was before TV, before radio, so newspapers were the only way. And there were all kinds of newspaper accounts of the William Palmer case, and people just lapped it up, just like, they lap up the tabloids today. And an interesting little footnote to the strychnine story here is the 1904 Olympics in St. Louis, which were held in conjunction with the World's Fair, which was also in St. Louis at that time. And Thomas Hicks, who won the marathon, was boosted by strychnine. Strychnine is a stimulant. And in those days, there were no laws, there were no rules about, taking substances during athletics. And he took strychnine to boost himself, just like one might take caffeine. And not only that, but you can see he was actually helped across the finish line by a couple of friends who just jumped out from the audience. And there was nothing wrong with that either. I mean, there was no rules against that in those days. But for strychnine, there actually is an antidote. And that was discovered by Pierre Fleury, a Frenchman, who found, and he demonstrated it in a foolhardy way, that charcoal was able to absorb any strychnine that had been ingested. And he became his own guinea pig. And he took some strychnine and he took some charcoal, and he was fine. And today, activated carbon or charcoal is still stocked in emergency rooms. And if anyone has swallowed something that is potentially poisonous, they're given charcoal because it will absorb a lot of material. So we've seen a lot of interesting things here, I hope, about poisons and toxins, but I leave you with one final creature. Absolutely fascinating one. This is the African crested rat, and it's the world's only known poisonous mammal. It's found in East Africa. And what it does is it rubs itself on the trunk of a tree, which is called the poison arrow tree, because natives in Africa have used that to poison arrows. And the trunk of the tree, the bark, actually contains a compound called ubain, which is highly toxic. So it coats its thorns on its skin. It's sort of like a porcupine, but they're not really quills. They're much softer. But it coats it with this poison so that a predator learns not to bite into this creature again. So as you can see, natural does not necessarily equal safe, right? Because we saw so many of the substances here that are natural and very dangerous. And that's why, I always tell people there's no such thing as a safe or dangerous chemical. It all depends on how you use it. Snake venom can kill, but you can also use it to cure, right? And this is where, science comes in. So I hope you have a little bit more insight now into poisons and venoms and toxins and all the interesting stuff that surrounds us out there in the world. Yeah. About what? Yes. It's called the poison garden. Yeah. Yeah, I've been there. It's fascinating. Oh, okay. I have to look at that. Because yeah, you have all the poisonous plants that I talked about there with the story on the plaque. But even more interesting than that, in Chelsea, in London, you have the Chelsea Physic Garden, which has all the medicinal plants. So you have one garden that has all the poisonous plants, and you have the other one that has all the medicinal plants. Yeah. How much? Water? Depends on what you're doing. I mean, marathoners have died from drinking too much water. It can happen. There certainly are recorded cases. I mean, you really have to make a huge effort, But yes, water can also kill you. Yeah, because it dilutes the blood too much. Yeah. No, I mean it doesn't have to be a horse. I mean it could be any animal. The only reason that they use horses is because the horses have a lot of blood, so that it's easier to extract substance. They could use humans too. Don't get too many volunteers. Yeah. I didn't get it. Sorry. Rice. Rice. Yeah. Yes. Yes. Rice can have arsenic because arsenic is found in the soil, right? It's a naturally occurring element. And rice is grown in rice paddies, which are wet, full of water, right? Rice needs a lot of water. So the water will extract some metals like arsenic and contaminate the rice. Generally, the levels are very, very low, and they are monitored for any rice that you buy packaged. It will be monitored. But there have been cases, mostly in Bangladesh, where people have eaten rice that had too much arsenic, but also because in Bangladesh, naturally occurring arsenic, there's a lot of naturally occurring arsenic, and wells get contaminated with arsenic, and then they use the well water to irrigate the rice. Yeah, so that's real. Yes. Absolutely. I mean, every pharmacological company investigates plants, hoping to find, the new morphine or the new digitalis. And there are hundreds and hundreds and hundreds of plants out there that have not yet been studied in any way. So yes, and for snake venom as well, because there's the search to see if there's any therapeutic drug that can be made from it, and also for making more effective antivenoms. Yeah. Yes, curare is used, uh, not exactly the same curare as in the plant, but synthetic derivatives that are modeled on it. And in fact, the first time that it was used in surgery was in Montreal in the 1940s at what then was called the Queen Elizabeth Homeopathic Hospital, which is still there today. It's the Queen Elizabeth Clinic. And so that's where curare was first introduced. Yeah. I think there's a chance. Yeah. But again, these are things that many companies are looking at, and they're looking at creatures that live deep down in the sea, places that we couldn't reach up, and now you have the technology to go deeper. So the natural world has given us lots of toxins and has given us lots of beneficial substances too. So yeah, there is a constant search for these, and you never know where the next major discovery is going to come from. Yeah. Oh, the ocean in the lake? Yeah, I don't know. I mean, yeah, there's lots of stuff out there to investigate. We're only scratching the surface of everything that's out there. All right, see you in December.